Welcome back, class. Today we're going to look at projectile motion problems. Here's the first problem. An angry bird is thrown 3 feet above the ground at a velocity of 100 feet per second and at an angle of 45 degrees with respect to level ground. The path of the angry bird is given by the function f of x equals negative 0.0032 x squared plus x plus 3, where f of x is how far the bird is away from the ground after x seconds. What is the maximum height reached by the angry bird and at what time? Before we start this problem, let's go ahead and label our x and y axis. We have our x-axis, which represents our time in seconds, and we have our y-axis, which represents how far the bird is away from the ground. Distance away from the ground. So now let's look at the first part of this problem. It says, what is the maximum height reached by the angry bird and at what time? So the maximum height is going to be located where our vertex is at. In our vertex, we know that x is 156.25 and y is 81.125. Let's analyze the coordinates of our vertex. X represents time, y represents the distance away from the ground. The maximum height reached by the angry bird is 81.125 feet at 156.25 seconds. Now let's look at the second question. How long will it take for the bird to reach the ground? Now look at the third point. We have our x value, which is 315.472, and our y value is 0. When y is 0, we know that the bird has finally reached the ground. So how long will it take for the bird to reach the ground? It will take 315.472 seconds for the bird to reach the ground. In the next question, it wants to know when the function is increasing. To increase means to go up. We know that our graph is increasing from 0 to 156. Okay, so on this side, it's increasing. And then on the right side, we know that our graph is decreasing. Our x value at our vertex is 156.25. And our x value from our starting point is at 0. And then where the bird ends, our x value is at 315. Let's highlight those. 0, 156.25, and 315.472. So the function is increasing when x is between 0 to 156.25. The function is decreasing when x is between 156.25 and 315.472. You can also read that as x is greater than 156.25 but less than 315.472. Now let's look at another problem. A rocket leaves a launcher at a height of 7 feet off the ground with an initial velocity of 144 feet per second. The equation describing the rocket's height after t seconds is h equals negative 16t squared plus 144t plus 7. What is the maximum height reached by the rocket and at what time? So we have this picture. We know that our x-axis represents our time, which is t, and that's in seconds. We know that our y-axis represents the height of the rocket above the ground. The vertex is 4.5, 331. Our x-coordinate is t, which is the time, and our y-coordinate is h. This is our maximum point. Based off the maximum point, we can see that the maximum height is at 331 feet at 4.5 seconds. The maximum height is 331 feet at 4.5 seconds. Let's move on to the second question. How long will it take for the rocket to reach the ground? If we look at our third point, we have 9.048, 0. Our h value is 0, our t value is 9.048, and because h is 0, we know that our rocket has finally reached the ground. It took 9.048 seconds for the rocket to hit the ground. Moving on, when is the rocket increasing? So let's divide our graph. We know that our graph is increasing from 0 to 4.5. Okay, this is 4.5. So when is the rocket increasing? When t is between 0 to 4.5. When is the rocket decreasing? Decrease. The rocket is decreasing when t is between 4.5 to 9.048. Now let's move on to our last projectile motion problem. A ball is thrown from the top of a hill. The graph shows the relationship between the height h in meters of the ball above the ground at the base of the hill and the time t in seconds after the ball is thrown. The function h of t equals negative 4.9 t squared plus 9.8 t plus 15 models h as a function of t. What is the significance of the vertex of the parabola in terms of the height and or time? Here are some additional questions that pertains to the problem. What is the significance of the vertex? If we look at the vertex, our vertex is at 1, 20. Our vertex represents the maximum height. So our x-coordinate is now t, which is the time, and our y-coordinate represents the height. It will take 1 second for the ball to reach a height of 20 meters. Now let's look into the y-intercept. The y-intercept is where the graph crosses the y-axis. Our y-intercept is at 0, 15. H is 0, t is 15. The y-intercept represents where the ball is thrown from, which is at 15 meters. Moving on. How long will it take for the ball to reach the ground? So let's look at this point, and this point is 3, 0. Our x-coordinate represents our time, and our y-coordinate represents our height. And because the height is at 0, we know that the ball has finally reached the ground. So how long will it take for the ball to reach the ground? It will take 3 seconds for the ball to reach the ground. Now let's look at increasing and decreasing. So I'm just going to draw my line of reflection or my axis of symmetry. That's going to help me determine where my graph is increasing and decreasing. So I know that my graph is increasing from 0, and I'm using my x values. So this is 1, 0, and we have 3. And on this side, I know that my graph is increasing. And on the right side, I know that my graph is decreasing. So positive, negative. The positive is going to represent my increase, and the negative is going to represent my decrease. The ball is increasing from when t is between 0 to 1. And then after 1 second, the ball is decreasing. So from 1 to 3.